Good evening, everybody. Welcome to week 2 of Lambda School's Mini Bootcamp. I'm Deandra Ryan Moss, and I am your instructor. So if anyone is joining us for the first time, let me fill you in a little bit. Lambda School is an online school, and it is an immersive for computer science and web development. So we teach you a variety of topics, everything you need to know about web development, from front-end web development and frameworks to back-end web development. We have you work through an entire web app project, and then we shift our focus to a more computer science-oriented curriculum. So we also teach you some object-oriented programming, some Python algorithms. So at the end of Lambda School, you come away as a really well-developed programmer, both with all of the practical skills you need to build things in the real world and with some more academic computer science-oriented background. And because we do everything online, it has a little bit of a different flow than your traditional in-person school, but a lot of the same components. So we do live video lectures using a software called Zoom that's collaborative so that the students can be a part of the classroom. As well, we use Zoom to pair up students so that they're working together in real time on projects. We also use some technology that you've already seen in this class, like Slack for general communication and communication with TAs, as well as GitHub for sharing code. So Lambda School is a really awesome way to learn how to code from wherever in the world you are. And what makes it even better is that we have a de-risked model, which means that you do not have to pay anything up front. Instead, we want to find candidates that are the kind of people who are going to learn and become amazing programmers. We don't want to have to choose people based on who can pay now. Instead of paying tuition up front, what you'll do is you'll pay us back your tuition over your first year or 2 years of getting your full-time computer science job. So if you do not get a job, we do not get paid. So it is on us to make sure that you get a job. Well, let's move on to the Mini Bootcamp, which is what you're in right now. So the Mini Bootcamp is totally free. It's available to the public, and it's our way of trying to get you prepped for the main curriculum at Lambda. So last week, we covered a handful of web development topics. You were introduced to HTML, CSS, and JavaScript, which are the 3 languages that power front-end web development. On Thursday, we introduced JavaScript specifically, and that lesson is going to be really important because this entire week we are going to be building on that and just learning more and more cool things we can do with JavaScript. So if you aren't up to date and you haven't seen that lesson and you're not familiar with JavaScript, that would be a good one to go back and watch before you do this one. And all these lessons are available on YouTube whenever you need them. Well, I'm going to go ahead and get started. As always, please be in Slack. I'll be sharing resources and answering questions at the end. And let's go ahead and learn some cool stuff today. So the first thing I want to talk about today is something called Nodejs. So Nodejs it can be a little bit of a complicated term to pin down because it's used in a few different contexts. But the way I like to think about it is it's the back-end version of JavaScript. So JavaScript was designed to be a web development language, a front-end language, which means that it is read by the browser. So when you write a JavaScript file, initially the only way for that to be read is through a browser. But that puts some limitations on what you can build with JavaScript. That means you can really only use JavaScript for web development or for front-end web development. But JavaScript is a powerful language, and we want to be able to use it in other contexts too. And that's where Node.js comes in. So Node.js is a way of running JavaScript on your local machine. So whereas just regular old JavaScript can only be run on the web, Node.js is a way to run it on your computer. In the real world, the main place that we use Node.js is in back-end development. So I've briefly mentioned back-end development. That's the side of web development that happens behind the scenes. That's the interface with the data. That's when you go to your Facebook page, for example, that's how Facebook knows what all those posts are that should appear on your page because the backend interfaces with the database and gets that information for you. Or when you create a new user or post a new post, the backend is what handles that data and makes sure that it's stored correctly in the database. Of course, we won't be covering any of the nitty-gritty of backend development in the Mini Bootcamp, but of course we get into it in quite a bit of detail in our main curriculum. So you might be wondering why I'm bringing up Node.js, and that's because we're going to use it for one very specific thing in this class, and that is running tests on our homework. And I do want to take a moment to apologize for not introducing this on Thursday. Unfortunately, we just ran out of time on this, but it would have been a little helpful for your homework. So I apologize for not getting to it Thursday, but I'm going to show you how it works today so you can use it with your homework moving forward. So I'm going to go ahead and share my screen so that you can see everything you need to about how to use Node.js to run tests on your homework. So give me just 1 second. All right, so the first thing that we need in order to use Node.js is we need to actually install it on our computer. So up here, I have the installer. I'm going to go ahead and copy this and put it in the Slack channel for tonight's lesson. It is also in the pre-course GitHub, but all right, this is a little confusing. It is in the GitHub for lesson 4, so that's Thursday's lesson. So if you're watching this and you don't have access to Slack, it's in the pre-course GitHub for lesson 4. So go ahead and install this on your machine. There's just an installer for Windows, there's an installer for Mac, and whichever type of computer you have, go ahead and click that and install it, and it should be pretty painless. So once that is up and running, you'll be able to use it via your terminal. So I have my terminal open here. I have gone ahead and CD'd into the pre-course repo, which is where you want to be. But you don't have to be there to first just test and make sure it's installed. So the very first thing that you would want to do to make sure it's installed is use the command line tool. So Node comes with a command line tool, which means that there are commands that aren't initially built into your computer, but when you install Node.js, they become available to you. One of those is just the command node. So when you do the command node, you can now, it opens a REPL, kind of like REPLit that we've been using. So now you could just go ahead and write JavaScript. So if I created a variable, and then there it is. So this isn't a command that you'll have to use at any point in this course. It's just a good way to test to make sure Node's installed. And it's a way to give you guys a little bit of context of what Node is doing, give you a tangible example of what I just explained about Node being a tool for being able to actually run JavaScript directly on your computer. All right, so I'm going to exit the REPL with this command. So now I'm just back to the command line as I was before. And if you want to, you're welcome. If you want to just mess around with some JavaScript, you're welcome now that you have Node installed to do this on the command line. But you're also welcome to continue to use REPLit online if you're more comfortable with that. So another command that comes with Node is something called npm. And npm is first and foremost a package manager, which means that it's what we use to keep track of all the outside code packages that we might use on a project. So in a production scenario, we'll be writing a lot of code, but we'll also be utilizing a lot of code that's pre-written and available online. And that's what we use npm for in the real world. So that's something you'll see a lot more of if you take the actual main Lambda School curriculum. But the only thing we are going to use npm for, which is just a tiny portion of what it does, is running our tests. So the very first thing you have to do is run npm install. And this has to happen inside the actual pre-course folder. So make sure that you are CD'd into the pre-course repo, or else this will not work. So I went ahead and did npm install. It was pretty quick because I've already installed. It might take a little longer if you're doing it for the first time. And this command only needs to be run once. So you don't have to run this every time you want to run tests, just once initially. So now that I've done that, I can go ahead and do npm test. So npm test is kind of a catch-all which runs all the tests, but we only want to run specific tests. So let's say we wanted to run tests specifically for our homework from Thursday. What we would do is npm test, and then we would do js1 or i.test. So this will take just a second, and it'll run all the tests on your homework for Thursday. Now, notice that this says that everything has failed. So the test suite, which is like the overall testing thing, has failed, and all 28 individual tests have failed. Well, that's because I have not touched this homework file from Thursday. It's exactly how it was found. So all these tests are going to fail. But let's say I start doing the homework. So one of the things you are asked to do is to create a string. So I'll create the string. You are also asked to create a number and a Boolean. So now I've gone ahead and I've done the first 3 homework problems. I saved my file, and I'm going to run npm test a second time. So once again, that's npm test, and then you do js1 or capital I dot test. So I run this again. And now 3 have passed and 25 have failed. So at least those first 3 homework problems are correct. So as you're moving through the homework, moving forward, you'll continue to run these tests as you go, and it'll give you some immediate feedback about how you're doing on the homework. So if you haven't finished your homework for Thursday, this is something you can use. If not, you can go ahead and use it moving forward. And I will go over this again, just very briefly at the end of the lecture to remind you guys how to use it for your tests or for your homework for tonight. Well, that is Node and NPM for you guys. Once again, just a very brief introduction into what NPM and Node are. We're only using them for something very specific in this mini bootcamp, but they're extremely powerful tools and definitely something that you will learn a lot more about in the main curriculum. So let's go ahead and jump into our topics for tonight. So let me pull up a REPL for you guys. And we can get started. So the first topic that I wanted to cover tonight is something it's kind of an odd standalone topic in JavaScript that doesn't really fit into any other category, but it's important to know about, so we're going to cover it. And that's undefined and null. So there are these 2 kind of categories of objects that exist in JavaScript called undefined and null. And they're kind of their own type. They sort of don't fit into any category. And they're 2 different ways of essentially expressing the same thing, which is that the variable doesn't exist in some way. And there's subtle differences between the 2 of them. In a lot of cases, they can be interchanged, but I'll try and cover tonight what the difference is. So I'm going to go ahead and start with undefined. So a variable is said to be undefined when no value has ever been saved into it. So you can think of undefined as feedback from the computer. It's a way that the computer can tell you, hey, this variable doesn't contain any data. So for example, we're used to seeing a variable name. We're used to seeing a variable declared like this. We use our const keyword, we name it, and then we assign a value into it. So number, of course, is not going to be undefined because it has this value of 9. But instead of saving the 9 into it, we could just declare the variable without putting any sort of value in it. So if we go ahead and declare this number variable, but don't save anything in it, Oh, I don't think you're allowed to do that with const. Excuse me. Let's try it with the keyword var, though. OK, here we go. So if we use the keyword var and we declare this variable called number, notice that the value of number is undefined. And as a little reminder of how REPL works, the very last line of code, whatever is resolved on the very last line of code, will appear over here in green. So we know that the value of number is undefined. It's never been set to anything. Another example of undefined that we briefly saw on Thursday is functions that don't have return values. So we talked about console.log, which is a really weird example because this function, console.log, it takes in 1 argument. The parameter is a string. The argument that I have put in is the word hello, and it logs hello to the console. So hello appears in white on the console. We always know something's on the console over here because it's in white, but the function itself doesn't have an output. It doesn't have a return value. So that means that this line of code resolves to undefined. Another example of a line of code that resolves to undefined is just a regular variable declaration statement. So this is This gets a little subtle here, but I think it's important. So when I run this line of code, it resolves to undefined. Why is that? Because we know we're saving a value into number. The reason is that this line of code doesn't actually give us the value of number. It doesn't really resolve to anything. So something happens behind the scenes. Something is created in memory, this thing called number, which is saved, which has 9 saved in it. But this entire line of code doesn't resolve to anything. There's no output from it. So when we run this as our last line, we get out undefined. However, if we see what the value of number is, we get 9. So there are 3 examples of undefined. Undefined is always kind of feedback from the computer about when something doesn't have a value in it, or when a function or a line of code doesn't resolve to anything. So let's look at null. Null is similar, but slightly different. So null also indicates that a value is missing, but whereas undefined sort of suggests that nothing's ever been put into it, null is more a way of saying the developer specifically wanted to tell you that there is no value. So here's an example of a time we might use null. So let's say we are creating some variables to represent students. So we might say, name equals Joe, age equals 29, and degree equals computer science. And then say we have another user called Sally, and Sally is 22. But let's say that Sally does not have a college degree. So what we would do as a developer is we would actually put in the value null. So that tells the user, okay, we didn't just forget to put a value in this, or it's not that we haven't gotten around to putting a value in it. It's just that there is no value. It's not applicable. So I like to think of null as being kind of equivalent to not applicable. So it's a way that we developers say, hey, this specific variable isn't applicable. And it becomes really useful in creating objects, which is something we are going to learn a little bit later. But that is the difference between undefined and null. And like many of these things, when you're initially introduced to them, it just seems like kind of a subtle nitpicky point. But the more and more you use them and see them, the more clear it's going to be, okay, this is undefined, this is null. And it actually becomes incredibly useful to be able to tell the difference between a variable not being defined versus being null. Like in this case, if this were set to undefined, which you can actually explicitly set something to undefined, but you usually don't want to do that. If I had done this instead, that could have been really confusing to my fellow developer, because they might think, oh, Sally does have a degree, we just don't know what it is. Whereas this suggests, no, she just doesn't have one. So that is undefined and null. As I said, kind of random standalone topics, but they're going to come up a little bit later in the main topic of what we're talking about tonight. So now that I've covered those, I can get on to control flow, which is the primary topic that I want to cover tonight. So let's talk a little bit about what control flow is. So we've seen some code like this in our lesson on Thursday. So or we can call that 3. So here's just a little bit of JavaScript code. What we're used to seeing is that the computer will read this code from top to bottom, and it will read, run, and execute every single line. And in general, in the most basic of cases, that's going to be true. If we just have a bunch of lines of JavaScript on here, the default is that the computer runs through and runs every single line in order. And that's great because that gives us a predictable way of writing code. If we didn't know what order the computer was going to read it in, then we would be in a lot of trouble. However, sometimes we do want to alter the flow of how the code is read in very intentional ways. And we need to do that explicitly so that we can sometimes execute one behavior or sometimes execute another without having to worry about things going totally out of hand. So the most basic way that we do that is with an if statement. So let's say that we have this Boolean variable called secret access. I'm going to set it to true right now. So if our user has the secret access, we want to be able to give them access to certain parts of our code. But if they don't, we want to keep things hidden. So let's say that we have a program that just logs a few things to the console. So the first thing it logs is, hello, how are you? So this is just a basic greeting. We want every single user to get that. But let's say that there's also this important secret message, which is that the bomb is going to detonate in 12 minutes. So we only want people with secret access to know that the bomb is going to detonate in 12 minutes. So we use an if statement to make sure that happens. So the idea is that this code only runs if the user has access. Secret access, that's fine. So what we would do is we use the keyword if, and then we put whatever code we want to only sometimes run within the if block. So let's go over the syntax here. So we start with the keyword if, and then we have a Boolean in parentheses here. So for now, we'll cover some more general cases, but in the most basic case, we want some sort of Boolean value to go in here, a true or false value. So if this thing is true, then execute this line of code. If it's false, we just want to skip it. So let's go ahead and see how this code runs. So it looks pretty good. We got the hello, how are you? And then we got the message about the bomb detonating, which we did want to get because right now we have secret access. But let's say that our user did not have secret access and this were set to false. So what we would hope is that this line would run anyways, but that everything inside of the if block would be skipped. And sure enough, it looks like we wrote our if block correctly, because when the secret access is false, this is totally skipped. So that is an if statement. Now let's say that we want to have one thing occur if the user has secret access and something else occur if not. So instead of just having a behavior when the user has secret access, we also want something to be logged if they don't. So that is where you would use an else statement. So an else statement is something that goes on the end of an if block. So we have our if block as usual, if followed by some sort of Boolean value in parentheses, and then followed by curly brackets. And then after that, we put an else statement followed by curly brackets. And let's say that if the user doesn't have access, we want to thoroughly convince them that there is no bomb. So we'll log, I promise there is no bomb in the building. Very convincing. So now we see, and I'll go ahead and just get rid of that first log. So if they have the secret access, we're going to tell them all about it. If not, we're going to reassure them that everything is okay. So right now this is set to false, which means that the else statement executes. And if we change this to true, then instead we get the first statement. So in any one execution of the code, only one of these two will be run. And we'll always get one or the other. It just totally depends on what secret access is set to. All right, let me show you one more, which is called an else if statement. So let's say that we also have another variable called enemy, or maybe is enemy. And that's true. So in this case, here's how we want the code to behave. So if someone has secret access, then we want to let them know that the bomb is going to go off. If they're the enemy, we want to keep them in the building. And if they're neither, then we don't really want to do anything. We'll just let them figure out, maybe they'll survive, maybe they won't. We don't care. So in this case, you would do else if is enemy. And now we'll say console log, why don't, full quotes. So if this user is our enemy, we want to trick them into staying in the building. So we're going to log, why don't you just wait here for a minute? I'll be right back, which is not something you want to listen to when there's a bomb in the building. I don't know why this example got so morbid. I apologize. So right now we have secret access being true, and let's say enemy is false. So in this case, the bomb is going to detonate in 12 minutes. Instead, if we swap these and say that they don't have secret access, they're an enemy, now we tell them to just wait here. If neither is true, nothing runs because neither of the statements were triggered. So I wouldn't worry too much about the else if statement. The if and the else are usually going to be the ones you want to master from the get-go, but I did want to introduce it. And one more thing about else statements, which is that else statements always need to follow if statements. So I couldn't do else and then this is going to throw an error. So else statements and if else statements always need to follow ifs, which kind of logically makes sense because how would you know what the else was in response to if there were no if? So that is the most basic case of if and else statements. And just one other example I wanted to show you is the case of a function, because a lot of the times these appear in functions, and you guys learned all about functions the other day. So let's say that we have this function called go for a walk. And it takes in one argument or one parameter called raining, which is going to be a Boolean. So if it is raining, I want to console log, we should stay inside. And otherwise, I want it to console log, we should go for a walk. So go for a walk takes in one parameter, a Boolean, and based on that, two different console log statements might occur. So let me go ahead and execute that. As we learned Thursday, you always execute functions with parentheses, and then you put in any arguments. So I'll throw in true as an argument. And if it's true that it's raining, we should stay inside. If it is false that it is raining, then we should go for a walk. So that's just a little use case example of putting an if-else statement in a function. You'll have to do some of that for homework tonight. All right, so let me talk about comparison operators. We saw a little bit of these on Thursday, but these become a lot more important when thinking about them in terms of control flow. So we saw that when you take numbers, you can use these basic comparison operators to get Booleans in response. So 4 is in fact less than 5, so we get true. If we swapped this and said 4 is greater than 5, then we would get false. We can also do greater than or equals to, as well as less than or equals to. So notice that if I do 5 is less than or equal to 5, I'm going to get true. But if I just did 5 is less than 5, I'm going to get false. There's one more comparison that I want to show you, which is a pretty commonly used one. This is the triple equals. So we're used to seeing equal signs in JavaScript with variable assignments. So if I have this line assigning a variable, you'll see that, I don't know why I commented that. You'll see that we use a single equal sign. And in JavaScript, a single equal sign means store this value into that variable. A triple equal sign means this is how we compare. So this is asking, is this first thing the same as this second thing? In this case, 5 is certainly the same as 5. If we change this instead to 5.5, it's going to be false. I do want to mention that there's also a double equal sign, which is also a comparison operator, but this one is a bit more subtle. It's kind of the best way I can explain it in a very short amount of time is that it's a way of saying these things are similar, but maybe not exactly the same. For your guys' case, I would always use the triple equals. You really shouldn't use the double equals unless you have a thorough understanding of what it does. And that's not something that we really have the time to cover here. So just always use the triple equals and you'll be safe. So we saw a few different ways of comparing here. You can do less than, greater than, less than or equal to, greater than or equal to, or equals. And let me just go ahead and show you a couple if-else examples of how we could use those. So if we have this variable called age, let's say set to 26, we could do if age is greater than or equal to 21, console.log, you can buy alcohol in the USA. So because the age is currently over 21, we see that this if statement says that you are allowed to buy alcohol. If this were set instead to 19, we would not get that statement. And in fact, we could add an else statement that says, you are too young. So now the else statement executes. So as I mentioned before, we want a Boolean value in here, but it doesn't necessarily need to be a variable that's set to a Boolean. It could instead be a logical operator that returns a Boolean to us, like in this case. I do also want to mention that while these operators are really straightforward when it comes to numbers, they still do work with other types of data, but they can get a little trickier. So for example, if I had two strings, and I went to, and I said name equals to other name, this would be a really good use case of this because clearly these are not equal and we get a false. But if I had two variables set to the same string, then we would get true. But if you start to do things like less than or equal to, occasionally you'll get weird and unexpected values. So that's another one where I would stay away from using greater thans or less thans with anything but numbers until you have a little bit more of a thorough understanding of JavaScript. Usually you're just going to get false though. So those are comparison operators, another really important part of control flow, because oftentimes that is how we determine what is executed, our if or our else block. Okay, now I want to mention something called truthiness, which is something that's a little weird in JavaScript. When I learned JavaScript, I was coming from Java, and this was one of those topics that I was a little appalled by when I first learned about, but after years of programming in JavaScript, I'm extremely thankful for it. So the two examples we saw so far with our if statements were something like this, where we had an actual Boolean value inside of our if statement, or we just saw an example where we had some sort of comparison operator in here. And we know that this resolves to a Boolean. But here's something kind of crazy, which is that we really can have any value in here. So for example, if we had this name variable in here, this would still work. Oops, excuse me. So every single variable in JavaScript is either truthy or falsy. I know that sounds like I just made those words up, but truthy, falsy. I'm not sure if falsy has an E or not, so I apologize if I spelled that wrong. And that's the idea that it's considered true by an if statement. So the first thing I want to show you is those fun things we learned about at the beginning, undefined and null. So as we know, let me actually set this up real quick. Truthy, else, console.log, falsy. Okay. So what's going to happen is if whatever variable, so we'll call this test var. So if our test variable is truthy, then line 7 is going to run, and it will give us some feedback on the console. If it is falsy, then it'll default to the else statement, and we'll get a different piece of feedback on the console. So using this little bit of code that I've whipped up here, we can test a few different things to find out if they're truthy or not. So obviously, Booleans we don't really need to bother with because pretty clearly true is truthy and false is falsy. But let's start with undefined, which we covered at the very beginning. So I have declared this variable using the keyword var, but I haven't saved anything into it. So that means that it is undefined. And we see that undefined is falsy. So let's try null instead, which we learned was slightly different. It's something that we explicitly define in, but it still kind of means there's nothing stored in this variable. So null is also falsy. So I'll start to make a list up here. Undefined, falsy, null, falsy. Okay, let's try a number. So if I put in 1, we see that that is truthy. So it turns out that almost every number is going to be truthy except 0. So numbers except 0 are going to be truthy, even negative numbers, truthy. But if this is set to 0, falsy. So something similar happens with strings. Strings are almost always truthy unless they're empty strings. So if there's just 2 quotes with no characters inside of it, it's falsy. Even if it's nothing but spaces, it's going to be truthy. But if it's empty, it's falsy. So up here we say strings except empty strings. And down here, we can say that the empty string is falsy. So you might be seeing a little bit of a pattern. Pretty much if there's content, it's going to be truthy. If it's undefined, null, 0, or an empty string, it's going to be falsy. And this is one of those where it will take you a little bit of time and a little bit of experience to start to learn, okay, this is going to be truthy, this is going to be falsy. And I also remember first learning about this and thinking to myself that this was incredibly stupid and I couldn't imagine using it. But as I said, it actually is really powerful. And just to give you a little bit of context of when this comes up, probably the most common place that it comes up for me is when there is an argument or parameter in a function that may or may not be passed in. So if I have a function that has some sort of argument, so oftentimes in JavaScript, you'll have a parameter of some sort, or let me change that to param, because that's a slightly more precise thing. As mentioned on Thursday, parameter is the general thing that goes in. An argument is a specific value. So the general parameter, there's one parameter, and it may or may not be defined. We're not sure. And the value of this function or the behavior of this function will change depending on that. So if I go ahead and run log stuff and put in pretty much any argument, like I'll put in the number 7 as my argument, it's going to run. And it is going to log truthy. But let's say I run this without any arguments. Now it becomes falsy. So this is often what you will see, is that sometimes, whether they're parameters in functions or keys on objects, which you will learn what that means at a later lesson, something might not be defined. And oftentimes you want the behavior of the code to depend on that. So in those cases, this truthiness and falsiness becomes really useful. So let's move on to another control flow related topic, and that is logical operators. So sometimes we want the behavior of an if statement to depend on more than one variable. So let's say we have we have these two variables called has car, which is true. I have a car, and has license, also true. So if both of those are true, then I can drive. So we want some sort of if statement that logs you can drive. And we only want this to execute if I have a car and a license. So in this case, we would use the and operator. So has car, double and sign, has license. That means that this will only execute if both variables are true or truthy. In this case, it works. But let's say that I'm licensed, but I don't have a car. Now we don't get that log statement because both of these need to be true. Another example is something called or. Let's say we had one more variable up here called risk taker. And let's say I'm a risk taker. I do not have a license, but I do have a car. You might see where this is going. So if I have a car and I'm a risk taker, it really doesn't matter if I have a license or not. I'm probably going to drive anyways. So, or excuse me, if I have a car, wait, I set this up wrong. Excuse me, let's do has license. All right, restart. So if I have a license, I can drive, but if I'm a risk taker, I'm probably going to drive anyways, even if I don't have a license. So this is where we would use the or operator. So we don't care if both of these are true now. We just care if one is true, at least one. So if I have a license or I'm a risk taker, then I can drive. So right now it says I don't have a license, but I am a risk taker. And you notice that this if block still ran. Let's go ahead and reverse these. So now I do have a license, but I'm kind of a rule-abiding citizen, so I'm not really much of a risk taker. But that's fine. I can still drive because I have that license. But now let's say they're both false. I don't have my license yet, and I'm not really much of a risk taker. In this case, because both are false, this is going to execute. And the final thing I want to mention about or is that it's inclusive, which means that it's totally fine if they're both true. It still runs. So one or both of these needs to be true, in which case this will execute. The final thing I want to show you is called the not. So this is a way of kind of flipping a Boolean. So it takes a true Boolean and makes it false. It takes a false Boolean and makes it true. So if I say not has car, then I can console log you do not have a car. So right now, has car is set to true, which means not has car is set to false. So this never runs. But if I went ahead and flipped this, now not has car is true because it's the opposite of this value, and this runs. And to make this even more confusing in the real world, sometimes you see crazy stuff like this mixed with this. You can really compound ands and ors and nots to your heart's content. If you're not familiar with formal logic, this will be really confusing at first, but just kind of start with the parentheses, write it down, go slow. But the good news is that you won't have to see anything this crazy in the pre-course. Just make sure you understand how and works, how or works, and how not works. Okay, the final thing I want to talk about today, which relates to control flow, is loops. So say I want to write some code that logs the numbers 1 through 5. So I could do console.log1, console.log2. This is starting to get tedious. I only have 2 more to go. And then here is the last one. So this is not good coding practice. We're going to come back to this idea again and again and again throughout the next few weeks, which is this idea of don't repeat yourself. Whenever you're writing something really tedious and repetitive like this, it's almost always a sign that you should be doing something slightly more sophisticated. In this case, what we want is a loop. So we saw that the control flow element of if-else statements was that sometimes one piece of code would be run or sometimes another piece of code would be skipped. Loops are kind of the opposite. In a loop, a piece of code will be run multiple times in a row. So in this case, we want console.log number to be run 5 times, but we want that value of number to change. So let me show you what a for loop looks like. So a for loop is kind of your most basic run-of-the-mill loop. So I'm going to write this out, and then I will break down the syntax. And I'm going to go ahead and have it log 0 through 5, actually. So here is my for loop. So this thing is going to log the number 0 through 5. And let's make sure it does what I think it does. Uh-oh. Well, that didn't work. What's going on? Oh, I switched these, didn't I? My bad. I usually use for each loops, which we will learn much later. There we go. Okay, 0, 1, 2, 3, 4, 5. We can see they are in white, which confirms that they are coming from the console as we had hoped. So let's break down the syntax. So we need some sort of counter variable that's going to change throughout our loop. And as a standard, we always use I for that. So notice that I'm using let instead of const. That's because i's value is going to be changing throughout the loop, which is a great opportunity to use let. If we use const, we get in trouble because const, once it's declared the first time, it can't change. So we get an error if we use const because we're trying to redefine a constant, and that doesn't work. So we want to use let. So this first bit inside of the parentheses tells us where do we want our counter to start. So I'm saying let's start it at 0. If I wanted this to do 1 through 5, like I showed you in the first example, we would just change the starting point to 1. And it goes 1 through 5. So we have right here, start. Then we have a semicolon. The next thing is our end. So this tells us when do we want our loop to quit. I have said when I is less than, or essentially it says when do we want it to continue, which kind of implies when does it end. So it continues as long as I is less than or equal to 5, which means that once I is greater than 5, we're going to stop. Finally, this tells us what to do with I each time. That's a little harder to articulate, but how about I call it how do we increment? And this means that I have to explain to you this plus plus operator. So this thing is pretty simple. Plus plus just means take this value. So if I have number equals, well, I'll do plus plus 10. That's saying add one value to this number and then store it in here. So sorry. Plus plus. I guess you can't use it with variable declarations in JavaScript. My apologies. So I'll just do 10 plus plus here. So, well, I'm trying to think of an example when you could use plus plus outside of a for loop, but nothing's coming to mind. So we'll just stick with the for loop. So this is just saying every single time we run through, let's add one number to our I and then increment it. So the first time we run this, so first loop, we're going to have I equal to 0, and then we're going to, we're starting with 1, excuse me, and then we're going to log 1. So then the second time we loop, now we've incremented I, so I is going to be equal to 2, and we'll log 2. And if we keep going, the value of I will continue to change. And so that's how we set up a for loop. So this is the most common way a loop is going to look. There are slightly other things we could do. For example, instead of doing I++, we could do I plus 2. And notice, uh-oh. Well, that's an infinite loop for us. Okay, we're just going to stick with plus plus. So this is incrementing I every time. And almost every case, you will do I++, which just tells it to increment. Or sometimes you will do I minus minus, which tells it to decrement. So say we wanted to start at 5 and go as long as I is greater than 0. Okay, so we start at 5. We want to continue as long as I is greater than 0, and then we want to decrease the value of I every time. So minus minus. So now it does the opposite. It counts down from 5. But let's say that, and we already saw a little example of this, that I accidentally messed up and said, as long as I is less than 5, we'll do less than equal to 5. So we're starting at 5. As long as I is less than or equal to 5, decrement it. So what's going to happen is first it's going to be set to 5, then 4, then the next time 3, etc. But notice that because we're decreasing the value, this will always be true. So that means that we'll have something called an infinite loop. And so I know we didn't see everything on screen, but it actually logged every single number from 5 to negative 12,854. And then luckily Replit has a built-in way of catching it. So it said, hey, we think you're infinitely looping. So we went ahead and quit this for you because we don't think that's what you wanted to do. So luckily, it's not the end of the world if you accidentally create an infinite loop, because pretty much everywhere you can run code, there's some sort of built-in process to stop it from looping forever and exploding your computer. But just be wary of that because you don't want to set up an infinite loop intentionally. You always want to make sure that based on how we're incrementing or decrementing and where the starting and stopping point are, that this will only run for a finite number of iterations. Well, that is everything I wanted to cover tonight. So we've gone over a lot of JavaScript topics. Hopefully you guys feel like you're diving in a little deeper. And before we quit for the night, we do have some time for questions. So let me pop on over to the questions channel and see what you guys need to know. Any questions tonight on either running tests in Node or comparison operators and truthiness, control flow loops? All right, it looks like we have one question on its way, so hold tight. So Leanne asked about Npm Install specifically in the pre-course. So let me go ahead and pull that up. So if you're, for every single folder in here, for every single lesson we're going to do is all within the pre-course. So yeah, so for this entire repo, you just need to do it once inside that main folder. But if you were working on some other project, some totally different repo that maybe you pulled down from GitHub, then yes, you would, assuming that they're using Node, you would need to do npm install. And usually you can tell that Node is present because you'll see this package.json file, or maybe you'll see, generally if this package.json file exists, that's a good sign that Node is being used and that you want to do npm install. So yes, Leanne. If you're in a different repository, you would need to do a different npm install. All right, any other questions? It looks like we had a question about the difference between double equals and triple equals. So that's not something I want to get into too much detail tonight, because as I mentioned, for your guys' purposes, the triple equals is what you want to be using. So triple equals is an exact equal. So I'm trying to think of a case. I almost never use the double equals, but I believe that null and undefined are a good way that we can do an example. So null and undefined are different, as we talked about at the beginning. So if I compare them using the triple equals, we're going to get false, because even though they're similar, they're not exactly the same. But I believe that, yes. So if we do double equals, then we get this. Then we get true because they're similar. So I, unfortunately, offhand, don't know every example of what's going to pop up for true when you're using double versus triple equals. But the high-level takeaway is that triple equals is going to be extremely strict about what it considers equal, whereas there's some wiggle room with double equals. So like I said, you don't want to use this until you feel really confident about what it does, because you'll often end up with unexpected results. So stick with the triple equals. Any other questions? All right, so you have some homework tonight for lesson 5. Let me pull up that again. So your homework will just be in here as expected. We have just some functions for you to fill out using some of these control flow techniques that you learned tonight. So once again, as just this little reminder, whereas for the example I did at the beginning, we did JavaScript 1, you'll just run JavaScript 2 instead. And this will run all of the tests for tonight's homework. So right now they should all fail because I haven't done any of these. But once you see those 21 greens, you know that you are good to go on the homework. All right, well, that is everything I have to share with you guys tonight. So hopefully you're starting to see a little bit of all the cool things that you can do with JavaScript. As always, please reach out on Slack if you're stuck on the homework. As I've said before, unfortunately, I don't have a ton of time in my schedule for asking individual questions, though you are welcome to reach out to me if you want. But the best place to go to start is just in the general channel where the TAs can help you out. So thank you for listening, and I will see you guys tomorrow as we dig a little deeper into some JavaScript topics. All right, have a great night. Bye, guys.